All right, this 14th, second to last one is definitely an interesting one, especially to me. This is part of the time series set of ICML 2023. This is Sequential Multidimensional Self-Supervised Learning for Clinical Time Series by Aniruddh Raghu. I'm sure I tortured that. They have an abstract and a paper. This is coming out of MIT and Harvard MIT program. Definitely looks interesting. Talking about time series, but applying it to heart failure. And yeah, I'll definitely be diving into this a little bit more later, but I wanted to read this to you. Just keeping you up to date. All right, here we go. Self-supervised learning SSL for clinical time series data has received significant attention in recent literature since these data are highly rich and provide important information about a patient's physiological state. However, most existing SSL methods for clinical time series are limited in that they are designed for unimodal time series, such as a sequence of structured features, for example, lab values and vital signs, or an individual high-dimensional physiological signal, for example, an electrocardiogram. These existing methods cannot be readily extended to model time series that exhibit multimodality, with structured features and high-dimensional data being recorded at each time step in the sequence. In this work, we address this gap and propose a new SSL method, sequential multidimensional SSL, where a SSL loss is applied both at the level of the entire sequence and at the level of the individual high-dimensional data points in the sequence in order to better capture information at both scales. Our strategy is agnostic to the specific form of loss function used at each level. It can be contrastive, as in SIMCLR, or non-contrastive, as in VicReg. We evaluate our method on two real-world clinical datasets where the time series contains sequences of 1. High-frequency electrocardiograms and 2. Structured data from lab values and vital signs. Our experimental results indicate that pre-training with our method and then fine-tuning on downstream tasks improves performance over baselines on both datasets, and in several settings can lead to improvements across different self-supervised loss functions. Nice. Okay, I hope you found that one interesting. This is second to last, the last one in the time series set. From what I could find is the sequential Monte Carlo learning for time series structure discovery, which I'll read on the next episode. Hope you enjoyed it. We'll see you later. Thanks, guys. Bye-bye.